This is Solidworks 2011 tutorials, Chapter 4, Creating a Brake Pad. So the goals of this project are to learn a few additional features over Chapter 2 and 3. We're going to learn how to apply a draft angle to an extrusion, apply color to various feature surfaces, and apply a couple of new sketch relations and constraints. So a few general tips to keep in mind as you're sketching on and this project and other projects. You can, if you uncheck the enable on-screen numeric input, what this lets you do is when you're drawing a sketch with the line tool, you can quickly switch back and forth using the A key between the line and tangent tools. The advantage of having this checked is that you can directly type in a dimension, and that makes it a little bit more like AutoCAD. So it's a matter of personal preference, but I will be drawing in this mode. You also can save time by creating a template part, and in this template you can set your own units, you can set default material properties and this kind of stuff. So if there's anything that you find yourself setting every time, it would be helpful to set yourself a drawing template for these parts. The drawing that we're going to be making today in inch, pound, second units here is the caliper brake pad. And so it's a relatively straightforward part. It's going to consist of three steps. We have an extrusion for the base. We have a drafted extrusion for this pad section. We can see from the side view here is sloped inwards at 25 degrees. And finally we have these holes to mount the brake pad on each side. The first step is to sketch the base profile, and we can see that sort of highlighted in blue over here. And what we're going to do is go to extruded boss / base, create a front plane sketch, and then just sketch the outer profile using a combination of a center line and the line tool. Sketch with the appropriate center line. We're going to start our drawing by creating one side of this object. So the best way to do this is to lock down a few pieces of key construction geometry so that the sketch doesn't move too much as we're working. So I'm going to refer back to the main drawing here. We have the most convenient outer feature to work from is this center of this arc and the hole here. So we know that this is symmetrically spaced 3.34 inches apart, and it is level with each other. So what we can do is draw a circle that is horizontal with the origin, since the origin location is somewhat arbitrary. And we can make the radius of that from our drawing. We know that it's 0.15, so we can specify that directly in our property window here. And then I can quickly and easily mirror this about my center line. And now we have that symmetrical feature, and this gives us the circle, or a reference circle, that we can then make into a center line. So zooming a little closer to the circle here, we can now start our outer profile using the line tool. And we're going to start horizontal here, go up, create a vertical line, and we know this is going to be approximately 0.35 or so. And so at this point we want to then switch to arc and avoid any of these constraints here that are implied. So we don't want to see any dashed lines. We're going to create an arc that's approximately 0.25 in radius, but it doesn't have to be exactly. Hit A to switch to radius mode again. We know that this guy here is going to be horizontal to itself because it's going to be symmetrical about the center. So we can create that, again, approximately where we want. We're going to select the center line in each endpoint of this arc and make it symmetric. So now that'll enforce a sort of mirror constraint. And at this point, we usually will sketch the whole sketch and then go back and add dimensions. But one of the things that we'll see is that making all of the dimensions at the end can sometimes cause large changes, and this can kind of screw up your sketch. So what we're going to do is anything that's easy to dimension early on, such as this vertical height, we're going to do that just to lock it down. So make that 0.35, give this a radius of 0.25, and give this a radius of 3. And then, so notice that we want to enforce this horizontal. So if it shifts vertically like this, all I have to do is select the center point of my circle and then click horizontal. Sorry, and the center point of the circle and the origin. I click the horizontal constraint in my properties window, and that forces these to be locked horizontal. So now we have, it's very similar looking, but now this shape here is partially constrained. So at this point, we can continue around. So I'm going to click this endpoint, hit A to draw an arc, and then we'll zoom in, and I want to put the arc on this construction circle that I previously made. Hit arc again, and here avoiding these snap lines as well, because we don't necessarily know the shape of this offhand. I'm going to hit A again after I create that, and we have an arc that goes the other way. Then A one more time to create this arc, and we are going to snap this to itself, because this again is going to be symmetrical. So we select the outer points, the center line, quickly add the symmetric constraint. And now at this point we want to, again, let's not let the shape get too carried away, so we want to specify the radius of this here to be 0.6. Similarly, this guy is also going to be a radius of 0.6. So now we can sort of see the shape coming together. Now, we'll notice that in our source drawing here, we have a specification that the center of this top arc is vertically 2.3 inches below the centers of these arcs that create the bottom of the part. So we can add that using Smart Dimension. We click each of these points, give it a vertical constraint, and we can see we're already pretty close, but we want to make that 2.3, so it's going to be a little bit shorter. 2.3. Okay, and so now we can sort of see why we want to constrain within reason as we go along, because large changes in dimensions like that will cause occasionally these distortions. We can see how this arc has kind of drifted down here to satisfy these constraints. So Solidworks isn't necessarily smart about this. It doesn't know what shape you're ultimately going for, so you'll have to coach it along as we go. So to help out there, I'm going to make this 0.11 inches as specified in our drawing, so we can see that these little guys are a radius of 0.11. And so finally, we've got one other constraint that's going to help us out here is the distance between these two circles, the construction circles that make up these arcs, is 1.65. So we can add that using Smart Dimension. Check on the center here, and now notice that it understands because I've selected a center line, it assumes I want a symmetric dimension. So I can just place that in the middle, make this 1.65, yes, and now we can see that the shape is a little bit more like what we want. And we can then, if we get out a Smart Dimension, we can sort of drag this around, and now we can see that as this shape varies, the different solutions that come out of this. So what's going to restrict this, you'll notice we haven't specified the radius of this guy, and that radius on our source drawing is going to be 0.15, or ever so slightly larger than this 0.2 hole. So if we make that 0.15, that'll make it a little smaller, and now we're starting to have this familiar shape. Okay, so we get out a Smart Dimension. We want to select all of the objects here that have not been mirrored over. So we can quickly do that, just all these arcs. And then we want to also select the center line, click Mirror, and now SolidWorks understands what we wanted to do there. We've mirrored those objects, and so now we should have a continuous solid section all the way around. So at this point, I want to quickly show you a useful tool to check if your sketch constraints make sense. So if we right-click, one of the options far down on the menu is going to be Fully Defined Sketch. So what this does is basically make sure that there are enough constraints in your sketch so that it can't be dragged around. There are no additional solutions. So we just take the default for now, select all entities in the sketch here, and then click Calculate. And we'll notice that right away it's highlighted these two guys as there being a conflict. So in order to try and overdefine it, it claims that the sketch as we've made it is overdefined. And so the reason that is because we've basically overspecified the symmetry here and the radius of this circle along with the tangent constraint. And now what constraints cause conflicts won't always be obvious, especially with more complex parts. So this can really be helpful in pinning down potential problem areas. So anyway, we've seen what can cause trouble. So I can, in this case, we know that this dimension is maybe causing a problem. So I'm going to experimentally delete that, go back into fully defined sketch, click Calculate again. And now we can see without that additional constraint, it can figure out what we need to add. So to show you how we can fix that, you'll notice here we've got this, I rolled back the sketch to the previous state, so we have this 1.3 dimension. So what I'm going to do is delete that and replace that with dimension here that sort of got lost while we were drawing it. We want to make that 3.34. What that'll do is now we can see it stretched the sketch out a little bit, and now we can see the combination of the equality constraint across each of these radii with the radius 1.6, and that final linear constraint. We have a nice fully defined sketch. So at this point we can accept this sketch. Since we've created an extrude, we can now immediately define those extruded properties. In this case, 0.1 high, blind. We're going to hit check, and now we have our first step. So the next step is almost the same. We're going to use extruded boss / base. Click on that front surface, and if it doesn't snap you to the view, we can go to the normal to option. And now we have a couple of choices. So we can see when we're doing, this is that the equivalent solutions that we can happen if you're not careful with your sketch. So before we move on, actually, I want to talk about this briefly. We've got, in this case, we can see two examples where both of these fully defined sketches have identical constraints, but because of the nature of the arcs, we have this tangent constraint at what you might describe as like an outer tangent versus an inner tangent. This Solidworks is not smart enough to differentiate because, as you can see, they are identically constrained. So you have to be very careful when you're using tangent constraints or when the changes you're applying create large changes in the sketch shape. So if you assign a dimension that's a big change, the solver may run into one of these problems. So the rule of thumb here, just to keep in mind, is try and constrain within reason as you go when you're doing a complex sketch with tangents, and try not to change the shape too dramatically in any one step. You have to sort of guide it towards the goal, of your part. Anyway, on to the pad extrusion. So we're again going to create the extruded boss / base, as I mentioned. And so we can, basically there's two different methods to apply here. We can use the offset tool to use the existing geometry. We can also create construction circles based on the existing geometry and then sort of sketch it, the outline based on those circles. So I'm going to show you method 2 here, which will be a little bit, there's a few more steps, but I think also easier to get the correct results. So anyway, we're going to create a circle, and then I want to try and snap this here to the center of that circle, and you can see that appears as a sketch constraint. And then once I draw it, I can assign that a radius of 0.5, and then I want to constrain it to that using Smart Dimension. Now, at this point, we can do the same thing with another circle. We want to see if we can lock this to the center of this guy. So it's a little tricky to get it to the implied restrictions to appear. So for whatever reason, this, like if we can't get that constrained exactly right, then you can also just directly make it concentric. If we, for instance, select this arc and your circle, you can apply the concentric constraint, which will make it coincide with the origin. So now we want to take advantage of some other constraints. If we select these two circles, I can click equal. That will make them the same radius. And now I can draw an arc using the 3-point arc, which is a new kind of arc. Essentially, we draw the start, the finish, when we draw this arc, the start, the finish, and then a point on the arc elsewhere. So this, we're really not going to be too fussy about where we place it because we're immediately going to switch to, after getting out of that mode, we want to switch to selecting the two features here, add the tangent constraint, then select those again. Want to make it tangent to the other side. Now in this case, you'll notice I tried to make a tangent two places. This won't solve the way it is because we have a vertical constraint between the center and this guy. So this is one thing, if you're not careful and you place it with that implied constraint, you want to, then you won't be able to apply this, the constraint you want. So if we delete that conflicting constraint, now the tangent is satisfied and we get this shape. Now this is almost what we want, but we can still, as you can see, drag it around. What we really want at this point is to have these two be concentric. So again, we just select the two objects, hit concentric, and now we have the shape we want. In the same way, we can use a 3-point arc, sketch in between, and then just draw this approximately the right shape. We repeat the same procedure as before. Tangent on the left, hit escape, select these two, tangent on the right, select this and our center arc here, make them concentric, and now all we have to do is trim out the center entities. So I did that again, if you don't remember, by clicking and dragging this line. Whatever that line that I draw intersects becomes trimmed away. So this becomes our completed, our fully defined profile. We're going to hit the sketch accept and then add in our boss extrude properties this draft on button, and we want to specify 25 degrees in the draft to make it taper on the outside. And now we can see this looks almost like a pair of goggles. This final version is tapered inwards. So the next step is to add color. We want to change the color of this to differentiate it from the base. And to do that, there's a couple ways. The easiest one is just to click Edit Appearance, and that will bring up this Edit Appearance tab here. Now, by default, it'll select the whole part. We want to get rid of that selection and click Select Faces instead. Now we can very easily select multiple faces. So I'll try that one more time. Click Faces here. Now we can see that the highlight selects all these guys, and we just have the 4 faces. We're going to hold Control and select each of those in turn. So it'll be a total of 5 according to this. So just make sure you have 1, 2, 3, 4 around the outside, and then 5 in the middle. And now we can specify a dark color like this, maybe whatever you want, to specify that this is a brake pad material rather than the part on the side. So the last step for this part is just to create the extruded holes. And this is really easy to do. We're just going to use the extruded cut feature. Again, snap our view so we can see it. And all we have to do is, in that same method, we want to sort of hover over here, get that constraint to appear, and make it concentric to each of these side holes. We're going to apply a smart dimension to create a diameter. And that diameter is going to be 0.2. And then at this point, we can, there's a number of ways we can do it, but the easiest way is to mirror it about, let's see, we'd have to draw a center line here. So we could just quickly draw a vertical center line, select 2 of these guys, and then create mirror. And now we have this nicely constrained hole on the opposite side. And the nice thing about a mirror is, since we want this feature to be in the same position and the same diameter, we can control both holes with one dimension. And that's the spirit we can see in our drawing as well. We just got to that. We can see the holes are specified as 2x, diameter 0.2. And so that's what we've done here. We click accept. We're creating a blind cut. Now you could leave it as blind through 0.1, but in the spirit of saving our dimensions, it would be smarter to do up to next, so that if the thickness of this part were to change, that hole would still be cut all the way through. So remember, this is part of how you express your design intent, if you want to do a blind hole versus a through hole. So we hit check, and we have all those features defined, and so this should complete the Chapter 4 exercise, the brake pad caliper.